Today we're tackling DP-750, specifically 5 questions covering data engineering concepts that trip people up on the real exam.
Yeah, we're looking at some seriously practical stuff, like saving state in Spark, cutting idle cluster costs, and, efficiently recovering failed pipeline tasks without just wasting compute.
Right, and the best way to really nail these concepts is to walk through actual exam questions, so let's jump right into some real problems so you can see how these topics get tested.
Sounds good. Where are we starting?
Well, picture this. You've got a structured streaming job, let's call it Job 1, and it's failing from transient errors. You need to resume it quickly and cheaply. So are you going to decrease the retry interval, bump up the cluster's minimum node count, set up a manual alert to restart it, or implement checkpointing?
I mean, in the real world, a lot of engineers are tempted to just throw more cluster nodes at it, right? Option B, like if it's failing, just give it more horsepower.
Wait, let me think about this. If you just give it more nodes, does Spark actually remember where it left off? Because a bigger cluster doesn't magically save the processing state.
Yeah, you caught me. Bumping the node count is a total throw money at the problem trap. It won't preserve your state at all. So the correct approach here is actually D, checkpointing.
Right, because checkpointing actually writes your progress like the exact offset logs to resilient cloud storage.
Exactly.
It's basically a video game save point. You die at the boss, you don't restart the whole level.
You just spawn at the checkpoint. That's the
Yeah.
perfect analogy. And setting up manual alerts, option C. That's an anti-automation trap. You really don't want a human waking up at 3 a.m. to click restart.
Definitely not. So speaking of wasting money on compute, let's look at the opposite problem. Say your all-purpose clusters are just sitting idle after users finish their queries.
Ugh, just burning cash.
Yeah. How do you cut costs without hurting active workloads? Do you rely on auto-scaling, convert them to job clusters, buy spot instances, or configure automatic termination?
Well, I hear auto-scaling option A, and I immediately think, it scales down when things are quiet, so that must be it.
I mean, that is such a common familiarity bias. We hear scaling and automatically think cost savings, but auto-scaling just adjusts the cluster down to a minimum number of nodes.
Oh, right, so it leaves the cluster running.
Exactly. It just dims the lights. It doesn't actually turn them off, which is why option D, automatic termination, is the right call here.
Like having motion sensor lights in an office.
Yeah.
Everyone leaves, the lights turn off entirely, zero wasted compute.
Yep. And spot instances, option C, might lower your VM costs, but if they're idle, you're still paying for a cheaper machine to do nothing. So we're saving compute when idle, but how do we start jobs efficiently without wasting compute while waiting?
That is the tricky part.
Let's say Job 1 must start only when new Azure Storage files arrive. Zero compute usage otherwise. Are we looking at a manual trigger, a file arrival trigger, a continuous trigger, or a scheduled trigger?
In a traditional pipeline, I'd strongly advocate for D, a scheduled trigger. Run it every hour, check for files, process them. It's just how we've always done it.
But the trap there is the empty run. If I schedule it, it spins up compute, even if
no files arrived, we're wasting money again.
You got it. Scheduled triggers are a cognitive bias toward traditional batch processing, and the continuous option C is even worse.
Right, that's like paying a security guard to stand on your porch 24/7. So the right answer is B, a file arrival trigger.
It's the doorbell camera. It actively alerts you only when someone walks up. Zero compute while waiting.
Love that.
Now that we trigger efficiently, what's the best way to actually build that ingestion pipeline? You need a low-effort way to pull cloud files, cleanse data, write to Delta tables, and handle monitoring.
Okay, so what are the options?
A scheduled Databricks notebook, Spark structured streaming, Lakeflow Spark declarative pipelines, or Azure Data Factory data flows. I lean toward A, the notebook. You can custom code anything in a notebook.
You can, but that is classic scope confusion. If you write it from scratch, you have to code your own monitoring and retry logic. It's not low effort anymore.
Right. So the smart play is C, Lakeflow Spark declarative pipelines.
Yes, because Lakeflow is specifically designed to handle ingestion and reliable Delta table creation natively.
It's like buying a meal kit where all the ingredients are perfectly portioned out, instead of grocery shopping and cooking from scratch.
Exactly. And beware option D, the Azure Data Factory trap. ADF is great for orchestration, but it lacks direct integration with managed Databricks Delta features.
Makes sense. But even the best meal kits get burnt sometimes. What happens when the final step of your Lakeflow breaks?
Now, this is the worst feeling.
Right. So Job 1 has 8 tasks. The final task 8, fails. How do you retry only the failed task? Repair the job run, update parameters, disable and re-enable the schedule, or just restart the job.
I'm going to fall for the classic IT anchor trap here. Have you tried turning it off and on again? Option D, just restart the job.
But if I do that, I'm throwing away all the processing from tasks 1 through 7.
Yep, they already succeeded. Restarting is a huge anchoring bias. The correct move is A, repair the current job run. Spark is smart enough to keep the successful tasks and only retry what failed.
It's like getting a flat tire and just patching the tire instead of throwing the car away and buying a whole new one.
Oh,
And options B and C, changing parameters or toggling the schedule.
just pure distractors. They won't magically isolate a specific task.
That's all the key points we shared for the DP-750 exam today. Thanks for watching. If you found this helpful, subscribe and leave us a comment.